Okay, so we're going to use our derivative rules from yesterday. Are you guys with me back there? Yeah? Okay, we're going to use our derivative rules from yesterday, and we're going to deal with it when we're actually multiplying or dividing. So this is on your formula sheet, both of these. So when you're multiplying two functions, and we're going to treat this as f of x, and we're going to treat that as g of x. We're treating them as both. There's a certain way that you do them. It's super simple. I know you're super excited. So when you're multiplying two functions together, it's add. Guess what's going to happen if I'm dividing them? Subtract. But these are kind of, like, none of the math rules ever change. They just get more complicated. But it's the same sort of thing. Product are going to change. So you would take the original function, times it by the derivative of the second function, and then add the original second function times by the derivative of the second function. Got it? No. It's okay. We'll work through it. So easy peasy. Because yesterday, would you guys agree that the rules were really easy? Like doing derivatives, using the rules was way easier than proving it using limits. Please tell me you found the rules easier. Thank you. Woo. All right. So, okay, so we can do it one of two ways. So method one is you actually multiply it out and do all your basic rules, which is pretty straightforward, not a big deal. So I'm still with the function, so I'm just going to multiply it out. So I'm going to have 2x cubed plus 2. No, let's try again. Let's try my multiplying better. Okay, so 2 times x cubed times 2, and then I'm going to have minus x to the exponent 7. Woo, that's a big one. And then I'm going to have plus 2, and then I have minus x to the exponent 4. Anything I can combine in there? I got cubes, I got exponent 7s, and exponent 4s, and a constant. Is there anything I can combine? No. Okay, if you can combine, do combine. Okay. So now we're going to do the derivative using our derivative rules from yesterday. Right. Easy peasy. Do you guys remember them? It was only yesterday. You're young, you guys have good memories. Right, so the 2 stays out front. I do the derivative of x cubed, that's going to give me 3x squared. Moving on, no coefficient out here, so it's going to be 7x to the exponent 6. What's the derivative of a constant? 0. I don't really need to write that in, but I'm going to just remind us. And this would be minus 4x cubed. So the derivative, 6x squared minus 7x to the exponent 6 minus 4x cubed. Do I want to leave it like that? Really? I could take out x's, I could take out x squares, but I don't want to, just in case I have to do a second level derivative. And you don't multiply that. All I'm going to talk about is the order. What's the best way to order it? Highest to lowest, right? You don't want people to make fun of you. I never want to send you out into the world. You know, you go to somebody's house to have dinner, and they're a lot more formal than your house, and they've got 3 forks on the table with parents and everybody had to deal with that. Like, I don't want to do that to you. You just say, are the chopsticks? No, like, you need to be exposed to it all, and I don't want to leave you. If you gave it to me like this would be 100% correct. I would be fine with this. I wouldn't lose my mind. I'm just saying, you know, I want to make sure you know how to use chopsticks when we go to your house for dinner. All right. So now we're going to do, have to be multiplied through. Why wouldn't I do this? I might not do this if there was 4 of them. I might not do this if the numbers were really ugly and I didn't want to multiply it. So method 2, use the derivative of the product. So here's what I like to do. So I'm going to split them. Actually, I'm not going to use f of x because the function is f of x. So I'm going to use k of x. It's a little much. And I'll use g of x. But I'm going to take, as a side note, I'm going to take the derivative of this really quickly. So k prime of x is equal to 3x squared. You guys okay back there? Yeah? Okay. And then I'm going to take the second function, which is, I'll call g of x. So that one is 2 minus x to the exponent 4. I'm going to do the derivative of it real quick. So negative 4x cubed. Right? Easy peasy. So all the thing states is you have two terms. So f of x, sorry, if I'm doing the derivative, that states the derivative of f of x, I'm going to take k of x and times it by the derivative of g of x, and I'm going to add that to the derivative of k of x plus the original function of g of x. You have them all here, you just got to put them in order. Okay, so I take the original k of x function, so that is the x cubed plus 1, times by the derivative of g of x, which is negative 4x cubed, and I'm going to add that to the derivative of k of x, which is 3x squared, times by the original function of g of x, 2 minus x to the exponent 4. Are you done? No. You're going to multiply them through now. So this is going to be negative 4x to the exponent 6 minus negative 4x to the exponent 3. I did that right, didn't I? So plus 6x squared minus 3x to the exponent 6. So if I combine like terms, negative 7x to the exponent 6 minus 4x cubed plus 6x squared. And if you notice, that's the exact same derivative as if you multiplied it in the beginning into the individual terms. Easy peasy, right? You guys want to multiply that one now? So that might be a great example of why multiplying the first number isn't where you want to go first. Are you guys with me? Whose birthday? Is it? Happy birthday, Mom. Should we call her up and say her happy birthday? Why don't you do that? And I'm not, but we're still talking about your mom's birthday. I don't understand. I don't see how that's any different. We're still talking about her and she's important. And it's not interrupting my lesson. I don't see that there's no one else here. I'm thinking my lesson's getting interrupted. We should interrupt her lesson too. What grade did you teach? That'll be fine. That'll be fine. What do you learn in grade 6? So this is a really good example of why I don't want to multiply things. Right? Why I don't want to multiply things. So my f of x function is my first one, so 2x cubed minus 6x plus 1. The derivative of it, 6x squared minus 6. Did I screw it up? Very good possibility. Right? Because this has a 1. 1 minus 1 is 0. Anything to the exponent of 0 is 1. Oh, thank God. I can go home now, right? Because that's as good as it's going to get today. G of x is this one. But I'm going to switch it up so I can have a rational exponent instead of a radical. Oh, sorry, that's the original function, not the derivative. That's just g of x. So g prime of x is 1/2 x to the negative 1/2. Can you guys do that in your sleep now? The rules are pretty straightforward, easy peasy. So if I'm doing the derivative of h of x, I take, you want to do 1 for 1. It doesn't matter when we're multiplying what order they go in. So it's going to be an original function times by the other function's derivative. So that's my first step. So 2x cubed minus 6x plus 1 times 1/2 g to the negative 1/2. Oh, and I so did not leave myself enough room. Plus, and this is going to be my second set. What's left over? So plus 6x squared minus 6 times by x to the 1/2 minus 1. Am I done? I would do this like that. Oh, it should be x. Sorry, where did I get the g from? Maybe I need to go back to grade 6 and do letter recognition. That's what I get. That's like bad karma. When you say something about a grade 6 curriculum that they can visit, then I can't even get my letters right. I wouldn't. And I read it like that. That's it. I was going further. Oh, Mr. Davey. I'm well. How are you? Did you know it's Sherry Horning's birthday today? No. Should I suggested we call her and sing her happy birthday, but we'd interrupt her lesson. That's fine. Okay, we were talking about Sherry Horning's birthday, so. Okay. Well, we did, but now we're not going to multiply it through because you know what? It's kind of a Friday for me, so we're going to leave our mouth like that. They are magical. Okay, so you guys are going to do this one. You guys are going to do this one and you're going to check your answer. I'm going to hit play again. Things we need to know. So it gets a little bit more complicated when we're subtracting because the order matters. Okay? Like addition doesn't matter if you add a 3 and 4 and get 7, or 4 and 3 you still get 7. But if you take 3 minus 4, you get a very different answer than 4 minus 3. Right? So now we got to follow these rules. Not too complicated, but just enough to cause you problems. Okay, so I'm going to call it my n of x, because it's my numerator, is 3x squared minus 4x plus 7. So my derivative of the numerator is going to be 6x minus 4. Okay. No, I said I'm going to say n of x for the numerator. Thinking. I love the mechanics. You guys are like the Waldorf and Statler in the Muppets. Like you're the back balcony that just like tumbles and beats each other, and this is where we are. Are we really calling mom? I love this. Okay, so I just did my side note. I feel like it's easier just to do this. If you don't want to do it, I'm okie dokie with that. All right, so order matters here. So this says original g of x function. G of x is the denominator. So the denominator first multiplied by the derivative of the numerator. So f prime of x is equal to g of x, which is my denominator, original function, so 2x cubed plus 9x times by the derivative of my numerator, which is 6x minus 4, subtract, which, blue or, I'm just going to get rid of that. I'll do it on the fly. Subtract the original numerator function. So 3x squared minus 4x plus 7 times by the derivative of the denominator, which is going to be negative 6x squared plus 9, all over the denominator squared. So the original function of the denominator squared. No. This is the best lesson ever. You don't have to multiply anything. There will be, okay, so see this? Differentiate using the quotient rule, but do not simplify. That is your key, not to multiply anything through. On the last page, we're going to be doing stuff. Like mathy stuff. Yeah, the whole page for what I know. Let's never define. Okay, so differentiate using the quotient rule, but do not simplify. So I'm going to do it without my side note, just for funsies to see if I can do it on the fly. So the derivative of f of x is the top. The top, I always start with the bottom. So it's going to be the original denominator times by the derivative of the numerator. So that's going to be 3x squared. Subtract. So if I started with the original denominator, that means I have to start with the original numerator times by the derivative of the denominator all over the denominator squared. Looks good. Good? Okay. So now I need you to emotionally prepare for this one. What did you find out? You can. Ever? No? Oh, there you go. Perfect. Good to know. Okay, so this question is going to be a question on your problem set. Not this particular one almost exactly like it. It says determine the equation of the tangent line to this equation at this point. what do we know? We know that f prime of x remember? We did that. We proved that. So we know that finding the derivative gives us a slope. Or the first derivative gives us a slope. The second derivative gives us a velocity. We haven't got there. So we'll deal with that in D6. But so the derivative is actually the slope of the tangent line. Oh, that's there. Okay, so the purpose, if I'm asking for the equation, if I'm creating an equation of any line, I need the slope and I need a point. I can find the slope using the derivative, and I already have my point because it's given here. Okay, you're going to substitute stuff in. First thing we're going to do is we're going to find the equation for the slope, which is just the derivative. I feel like I've lost you. I feel like today has been like I'm competing against Sherry and the grade 6 lesson. I'm doing the 3 times 3, so I'm doing the derivative, right? All over the denominator. Oh, geez, Louise. Denominator is really fascinating. This one, well, we can do it one of two ways. We can simplify it first, or we can sub in at this point. You don't want to simplify? You can do it either way. There's benefits to doing it either way. If you're going to substitute in now, just watch your positive negatives. I might go with substitute in now because what's my x value? It's a really nice one to sub in. You know what also is a really nice number to sub in? 0. So you can sub in from this point, or you can simplify through. What do you guys want to do? Sub in? No, you're not bothering. It's a Friday. We're not simplifying. It's a Friday on a Wednesday. So 1 minus 2 times 1 cubed times 9 times 1 squared minus 3 times 1 cubed plus 4 minus 6 times 1 squared all over 1 times 2 times 1 cubed all that squared. All right, here we go. So 1 minus 2 is going to give me -1 times by a positive 9. Subtract 7 times -6 all over -1 squared, which is positive. So I have -9 plus, what's 7 times 6? 42. All over 1. So what's 9 from 42? 33. So the derivative at x equals 1, it has a value of 33. Okay, so what does that 33 represent? The slope of the tangent line. So the slope is 33 of the tangent line when x is equal to 1. Why do I need that -7? I need that to find my actual equation. So I got my slope, and my point was 1 and -7. When I have those two things, I can use slope point form. Grade 10. Yep. And then you're going to square it, right? So it's slope point form. Y minus y1 equals m times x minus x1. Y stays. Y1 is -7, so it's going to be add 7 equals the slope of 33. X stays. 1 gets substituted in there, so I've got y plus 7 equals 33x minus 33. Subtract 7 from both sides. Y is equal to 33x minus 40. So that is the equation of the tangent line at x equals 1. You guys remember when this stuff was really, really hard? Like grade 10, when like slope point form was just like boring, and then you had to rearrange stuff, and it was just the worst thing ever. What? You did slope point form. I believe I taught it to you. When are you going to know Alice was? Alice, I'm calling him. Call me now. I'll text him right now and tell him. I didn't teach slope point form. I offered to call Sherry. You kibosh that. Did I not? Did I not say?